This is a custom built machine that helps you do pull-ups and dips, even if you're not strong enough to do them unassisted. It uses a counterweight system and a sliding platform to reduce your effective body weight. No springs, no bands, just simple mechanics. But it didn't start that way. The concept's straightforward. You kneel on a padded ledge, which is connected by a pulley to a counterweight, add more weight to the counterweight, and it offsets your body weight, giving you a boost when doing pull-ups or dips. The machine also includes removable handles, so you can switch from pull-ups to assisted dips. And the kneeling pad, that's removable too. You just loosen the locking nut and it slides right out of the way, which is handy if you want to use the bar unassisted. On the first version, I used open linear bearing blocks, 2 per vertical rail, 4 in total, all welded to a steel plate that held the kneeling pad arm. But under load, things started binding up. At first I thought it was a tolerance issue, or maybe the bearings just needed to wear in. I tried greasing the rails, but the real problem was how the force was being applied. When someone kneels on the platform, the force isn't just vertical, it creates torque. That downward pressure tries to twist the whole platform, pushing the bearing blocks outward against the rails. The opening bearings just couldn't grip tightly enough. They were fine with light load, but as soon as the weight was applied, they started to flex and jam. Now, I'm not an engineer. If I was, I probably would have calculated the torque loads and known that up front. But I work more by intuition and testing, so this was just one of those lessons I had to learn the hard way. And $200 for the first failed set from AliExpress. It cost more than double that the second time from an Australian supplier. I didn't want to risk it again. So the rails were the most expensive part of this build. To fix it, I replaced the open bearings with closed linear bearings, which completely wrap around the rail and provide full contact support. That change, plus a few tweaks to the rail alignment, such as positioning the rails further out, closer to weight loading, as well as a bit more spacing between the bearing blocks, completely eliminated the binding. Now, the platform glides smoothly, even under full load. The closed bearings effectively resist the rotational force. They hold tight to the rails instead of shifting under pressure. Small changes can make a huge difference. In terms of materials, most of it's just 50mm angle line. This stuff's 5mm for the main backbone of the machine. Then in other areas I've just used 3mm angle line where it didn't need as much strength. The plate holding these brackets is a bit thicker as well to make sure it didn't warp. But then everything else is just square hollow section. I think this is only 2.2 or 2.5mm thick. Same with these dip bars. This cable I just got from a local hardware store. I just crimped the brackets myself. Pretty straightforward with a pair of multi-grips and a hammer. Another important part of this machine, because it's quite skinny, is this bracket here, which it's welded onto a wall bracket that's bolted into the wall of the shed. I know the shed's pretty solid behind there with hardwood battens, but on this end, the gym machine, it's just got bolts that I can remove. So if I ever want to move this thing, just unbolt that. This bracket's independent. This is really important to stop it moving around. The foot of this entire machine has just got a couple of bits of 50mm by 3mm angle line on the outside. And then this is the thicker 5mm angle line along the middle here that's welded onto the bracket itself. Seems pretty stable. I had to pack it out a little bit here with timber because the shed slab is not level. But that's dyno bolted into the shed as well with 4 bolts. These brackets here seem a little bit of a weakness to me. They're quite small. I'm not sure what would happen if you drop the ledge heavily down onto these, whether it would snap them, but so far they've been okay. We've been using this for a few weeks and it hasn't failed yet, so we'll keep an eye on these over time. There's 2 down here and 2 at the top. Looks like there's a lot of bolts on this plate, but there's 3 in each one of these 4 linear bearing brackets. You can see the key here which just tightens into the ledge to hold it in place. I've got a similar thing for the dip bars as well. For the kneeling ledge, just a frame screwed onto a bit of yellow tongue flooring. There's a little bit of 3mm in there just to give it a bit of space here, so it's got room to slot into the machine. I use this vinyl material off an old gym bench and it's just tacked into the wood. It's a bit of a rough job, but it does the job. It's got some blue camping foam underneath here. So this stuff, it's like $5 a roll from the camping shop. Pretty cheap stuff. Just takes a bit of pressure off your knees. We've been using this in our gym sessions for a while now. It makes training way more accessible for people still building up to unassisted pull-ups or dips. And because the assistance is mechanical, it's easy to adjust. We just chuck some extra dumbbells on to make it easier. Snapping between dips and pull-ups takes seconds, and removing the pad opens up for full range bodyweight work as well. The next modification I'll make is replacing these cheap pulleys with bearing pulleys. These add unnecessary friction without the centre bearings, so I intentionally didn't weld them in too thoroughly for easier replacement. Let me know in the comments if you change anything or if you'd like to see more projects like this. There's a ton of stuff you can do with pulleys and some basic welding skills. Thanks for watching, and I hope to see you soon.